All right, welcome to my unboxing of the Huina 1850. There's a bunch of different models of these. This one is the Top Race TR-211M metal, but these are all the same machines, and there's no information about the board and the connections. I looked, so I had to go through and figure all this out myself. And since I went through and did this, I figured it would be useful to somebody to see this information so they don't have to struggle like I did and test everything and cut things apart, move sensors to their limits to see what sensors activated and all this stuff. So first of all, it's the controller, everything is great. I mean, I've used this machine a little bit. I've just played around with it. It hasn't seen dirt yet, but I will say it seems like a quality machine. I haven't seen any junk here. I haven't seen too much as far as anything being bad. This wire had slight damage where it comes through the battery, and I'll zoom out and show you the big picture in a second, but I had a little bit of damage on the power wire, just a slight nick. I just put electrical tape on it, and then it is kind of in a rough area, so I just decided to do extra electrical tape. There was just a tiny nick here, but I decided to protect a bunch of the wire here. Anyway, let's get into the board. So starting with your boom motor right here, and then this should be your slew motor, which has this is your slew motor. It's got a drive pinion here and the ring gears down in here. So this motor activates, spins a pinion gear here and rotates the machine. This machine here, this motor here, drives the worm gear. And you can see this, we'll look at that too, but you can see there's a gear on the bottom of the boom. This motor drives the worm gear at the bottom that rotates and moves through the teeth of that to move it up and down. So where on a conventional excavator, the left stick is boom up, boom down, and rotate or slew the machine. Now, in the case of this model, the left stick was doing the stick boom and rotation, and the right stick was doing main boom and bucket. So the bucket was fine. We didn't touch the bucket. What I did is I took the connection. So the blue connector here, the bucket is on the red and white wires. Those have not been touched because the bucket is fine. But the white and green wires were what were previously controlling the stick boom. So I took these wires and I cut them and I connected them with the correct polarity. So I went green to black and white to red. Okay, so this moved my control on the left stick, which was doing the stick boom, to the main boom. Then I moved over here. This was our main boom connection, and I did the exact opposite. I cut the wires and I connected my red out to my white in, going to the servo on the boom. Then I took my black out on the red connector and I connected to the green wire. That's going to move your right stick, which was the main boom, to the stick boom. So that will set your controls up for conventional excavator operation in America. Apparently ISO controls overseas are the way this is designed, but that's not what I'm used to. I don't want to remap my brain. I want to remap the machine to suit my needs, okay? Customization, configuration, make your life easy. Okay, that wasn't the end of my problems though, okay? These connectors, you got a red connector with 4 pins and you got a white connector with 4 pins. These are your limits, okay? So I switched these over and then immediately realized that when I reached the limit on my main boom, my stick boom wouldn't move and vice versa. So I had to move these over. Now I cut all these wires because I had to do testing and I had to move everything through its rotation to see when I got power, because these limit switches are they're creating continuity for voltage to flow, okay? So you don't need, on the red connector, you don't need to touch your green and your white. I disconnected them and respliced them, okay? But you can ignore them. If you want to do this modification, all you need to do is cut your red and black on the red connector, and then you need to cut your white and green on the white connector, because this is your bucket limit switch. We're not doing anything with the bucket. So on the white connector, your bucket limit switches are your red and black wires. We can ignore those for now. So what you want to do on the white connector is you want to connect your green wire to the black wire that you cut off the red connector. Then you want to connect your white wire on the white connector to your red wire that you cut off from the red connector. Okay, we're going to do the exact opposite on the red connector. On the red connector, we're going to take our red wire and we're going to splice it into our white wire that we cut off the white connector. We're going to take our black wire on the red connector and we're going to connect it to the green wire. Okay, once you've done that, and I'm going to demonstrate this, actually, hold on. So once you've done that, you've fully modified the machine to swap the controls, and you've kept your limit switches, so you're not going to overdrive your motors. I did think about not doing limit switches, but it's just, you know, everybody makes mistakes on the controls. You got to have those safeties in place so that you don't damage your gearing. But before we switch over, let's just make sure we've gone over everything on the board. Okay, so I know these videos kind of suck because we're looking at a board. It's hard for me to get light in here properly and show you everything, but I'm just going to show you this, I believe, and I haven't tested this, but this should drive your tracks. Okay, this is why it's such a heavy duty connector and the wires are thicker, is because this requires quite a bit of power. So when you're driving this around, that's what's really going to drain your battery, is driving it around. Just operating the boom, judging by the wire gauges, and the voltages, your sensors are, the board says 5 volts. The only thing that's in English on the board is 5 volt and ground. The others are Chinese symbols. That's why I couldn't figure out what was going on here. I see 3.3 on these, and I see 7 volts, full 7 volts on the other wires, but they're pretty small gauge, indicating that they're not drawing a lot of amperage. These are pretty small motors. These are pretty small servos, but they're appropriately sized and they do a pretty good job. They've got quite a bit of power. This connector here behind the green connector, this is your smoke machine. I'm about to remove that. We'll talk about that a little bit more. I'm also going to remove the battery compartment to give myself a little bit more room and a little more flexibility as far as what kind of batteries I can put in here. But this white connector behind the green right here is your smoke on and off. This is your tracks. This is your power in. We already talked about the blue connector. We already talked about the red connector, yellow connector. So the only thing left is the green connector. And I have not tested this or cut any wires, but the only functions that are left is your auxiliary output for the hammer on the stick boom and your lights. So I believe that the green connector is going to have one side being your lights and the other side is going to be likely that auxiliary output. And that should be the whole board, okay? The only other thing is the antenna on the bottom of the board directly soldered in. So now let's zoom out and I'm going to show you the operation. Hopefully that was in focus so that you were able to see that, but let's take a look at the machine actually operating now, and I'm going to show you the controller as well. So all right, let's first get this battery on here. Whoops. Just want to make sure that you're going to be able to see the whole thing. So, all right, so left stick right here, boom, up. Limit switch, engaged, motor will not function. You don't have to worry about this. Lights still work, everything still works. It's all, just the controls have been swapped. Everything is still functional. So this is all the way up, won't go up. Let's go boom down. Boom, down. All the way down. Will not continue to function. All right, stick boom in. All the way in. Will not continue to move. So just as it came from the factory. On the way out, I notice if you go full speed, it goes a little bit past, which is fine. But if you go slow, it doesn't quite have the same amount of travel. But again, stick boom all the way out, motor won't function, servo won't function right here. Stick boom all the way in, just to also show you the range of movement on this machine. I feel like a lot of people don't give you that. And then we're gonna do a digging video, so you're definitely gonna see the limits. And then this is our bucket function. Same thing, limit switches are still functional. Bucket all the way open, stick will not move the servo. Bucket all the way closed, we cannot over travel. So everything is just the way it was from the factory. The other thing I want to talk about, this thing does not come properly greased. You know, are you a miniature machine operator, or are you just someone who's gonna show up to the job site and use your equipment without properly greasing it? If you're an operator, you need to grease your machines, and you should be doing this every couple of months. All you do is you take this screw out of the stick boom. This will release the end. You got a little cap on here, you take that cap off. Then you just manually spin the end off. You take off this piece, it's threaded inside here. There's a big screw drive in here, so you just back it off, pull it out. Take some white lithium grease, whatever you got, any grease you got, any hard grease that you have that you would use on real equipment. Take this out and just pack a fingertip full into the back of this screw and then screw it in. And I noticed a huge difference in the quietness, other than the servo, but the quietness of the gear and the motion. So this is full of grease. Not full, but I mean, I put a fingertip full and it's distributing itself through the screw as you move it. Same thing for the bucket. You take this, let me make sure it's in frame. You take this screw right here, which takes the cap off this and leaves it uncaptured, so you can screw that one off. Put a fingertip full of grease in there, put it back on. Put your screws back in. If your limit switches are active, it doesn't matter if you get it perfect. The machine is going to stop its travel based on the limit switches. So you can take it out while it's fully extended, and then you can screw it all the way in and put your screw back in, capture it, and turn it on and start operating, and it will not over travel.